Hello and welcome to the 17th episode of the Python tutorial series. Today we will look at some key NumPy functions and methods. First, as usual, let's import NumPy by writing import NumPy as NP. Now the first function we'll look at today is called aRange, and we can write np.arange. Now, doesn't this function look like something we've seen before? Well, of course it does. It looks like the range function. If you can't remember how to use that, make sure to check my tutorial on the range function by clicking in the top right-hand corner of your screen. Now, for those of you who need a quick reminder, the range function works by creating a set of evenly spaced numbers from A to B using integer spacing. However, what if the spacing weren't integer, but had to be, say, in 0.5 increments? Well, this is where aRange comes in. The advantage of using the numpy.arange function is that you can again create a range of values from A to B, in this case let's say between 1 and 10, but the step can be any kind of number. So in this case, let's say we want to do it in steps of 0.5. So this will create an array, of course, and in this case you can see the numbers range from 1 to 9.5 in increments of 0.5. Now, having seen the aRange function, what if we want to create the same range of numbers, but instead of using the step, we want to define the number of elements that are within the array? Well, this can be done easily in NumPy using numpy.linspace, and again we can give it the same extremities, so 1 to 10. And in this case, instead of specifying the step, we specify the number of elements that will be inside the array. In this case, remember that the number 10 will be included. So the number of values that we want to include in order to have a spacing of 0.5 is 19 numbers. So if we run this, you can see that it will generate exactly what we want. The values 1, 1.5, 2, 2.5, etc. In this case, remember, this is one of the very few, if not the only case, where the end number, the number 10, is included in the final array. Having seen the aRange and linspace functions, what if we now want to generate a matrix of values where all the numbers inside it are zeros? This can sometimes be very useful in coding. Well, NumPy allows us to do this with one simple command called numpy.zeros. In this case, we can give it a shape of, say, 3, 2, meaning that it will contain 3 arrays, each with 2 elements. As you can see, this is exactly what has been produced. An array containing all zeros with 3 smaller arrays, each containing 2 elements. So this is what you would define as a 3x2 matrix of zeros. Another typical case would be to have the same matrix, but with all number 1s instead. Well, as I'm sure you can guess, NumPy also allows us to do this, simply by calling numpy.ones, and again we can give it the same dimensions, and this will create an array with all 1s. The final array that we will look at today, which can be extremely useful in coding, is an identity matrix. Now this can be done with a simple command called EYE. In this case, it will take only one number, which is the size of the matrix that we are going to create. Because as you know, an identity matrix has to be a square matrix. So we can say 3, and this will create a 3x3 identity matrix, where the diagonal has 1s and all the other values are 0. Now we will look at 3 functions that are used to modify the shape of these arrays. So first, let's create an array. Let's say A equals numpy.array of the numbers 1, 2, 3, 4, 5, 6, 7, 8. Now if we want to change the shape of this array, we can use the numpy.reshape command. But we have to do that by calling the name of the array first, and then doing .reshape, and then stating the shape of the new array we want to create. So in this case, let's say we want to create a 4x2 matrix. So if we press enter, we will of course get the new array that contains 4 elements, each with 2 numbers inside. So as you can see, the one-dimensional array has been reshaped into a 2-dimensional array. Now, before we look at the next 2 functions, let's create a quick 2x2 matrix. We can call this x and say that it is equal to numpy.array of, say, 1, 2, 3, or 1, 2 actually, better still, and then 3, 4. And if we look at x, x will be an array with 2 elements, each containing 2 numbers. Now, let's look at 2 functions. The first is to transpose this array. We can do this simply by doing numpy.transpose x. And this will move the 2 elements outside of the main diagonal. So if you notice, the number 3 and the number 2 have switched positions. Now here's a top tip. If you want to transpose a matrix without having to even call the numpy function, just use the name of the matrix, put a dot and a capital T. If we press enter, you can see that the effect is the same. The matrix has been transposed correctly. Now the last function we will look at today is part of a sub-library contained within Numpy. In particular, this is the numpy.linalge sub-library. This is a library that allows you to do linear algebra, and in particular it has one function called .inv. What this does, as some of you can imagine, is it inverts a square matrix. So if we call the matrix X, this will give the inverse of the matrix. Now after all that matrix magic, that's it for today. In the next episode, we will look at another set of very useful and widely used NumPy functions which are used to generate random numbers. I look forward to seeing you next week, and in the meantime, don't forget to like this video, subscribe to the channel and turn on notifications so you don't miss any upcoming videos.